Hello everyone, I am Professor Amit Solanki from SND College of Engineering Research Center, Yola. Now today we will start the Unit 3. His name is Single Phase Control Rectifier. So let us discuss and start our third unit. Before starting the topic, we will discuss here the syllabus content of the unit 3rd. In that syllabus, first that will be single phase converter. In that fully controlled converter, the rectification inversion mode, half control converter, their semi converter, operation of all converter with R and RL load, derivation of average and RMS output voltage, power factor, TSD, and TUF, transformer utilization factor. Next part, the numerical based on output voltage and current calculation, effect of source inductance on operation of converter, concept of overlap angle and voltage drop calculation, single phase dual converter, descriptive treatment only. So we will discuss the introduction part of the unit 3rd. Unlike diode rectifier, phase control rectifier has an advantages of controlling the output voltage. Okay. So the diode rectifier are called the uncontrolled rectifier. When these diodes are replaced by the thyristor, then it becomes phase control rectifier. And the output voltage can be controlled by varying the firing angle of the thyristor. And this phase control rectifier has its main application in the speed control of DC motor. So in that figure, in this slide, you can see here the phase control rectifier, the basic block diagram of the phase control rectifier. In that, you can see here this is the AC input voltage, okay, and this is the AC input voltage, okay. This is the block for the phase control rectifier, and here we are getting the output voltage, that is the DC output voltage, okay. So the input supply fed to control rectifier, that will be AC supply at fixed RMS voltage and fixed frequency, okay. And we can obtain the variable DC output voltage by using the control rectifier. So this is the basic fundamental concept of the phase control rectifier. So by employing phase control rectifier or thyristor in the control rectifier circuit, we can obtain variable DC output voltage and variable DC output current by varying the firing angle or triggering angle at which the thyristor are triggered. We obtain a unidirectional and pulsating load current waveform which has a specific average value. Okay. Now we can see here the applications of the phase control rectifier. The DC motor control in steel mills, paper and textile mills, employing the DC motor drives. There are various applications of phase control rectifier. We will see here one by one. AC fed traction system using DC traction motor. Next application, that is the electrochemical and electrometallurgical process. Next applications, magnetic power supply, then reactor controls, then portable hand tool drives, then variable speed industrial drives, battery charges, HVDC system, UPSC system. These are the basic applications of the control rectifier. Now we will discuss in detail the single phase half control converter with resistive load. That means R load. Single R load we can connect and observe their behavior and characteristic with circuit diagram and waveform. So this circuit consists of thyristor T, voltage source Vs, and resistive load R. So first we will see their working principle. So during the positive half cycle of the input voltage thyristor, T is forward biased, but it does not conduct until a gate signal is applied to it. When gate pulse is given to the thyristor T at omega equals to alpha, it gets turned on and begins to conduct. And when the thyristor is on, the input voltage is applied to the load. But during the negative half cycle, the thyristor T gets reverse biased and gets turned off. So the load receives voltage only during the positive half cycle only.